Hi to everyone. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject robotics, machine and vision system, unit number 5, morphology. So last class we discussed about the basics of digital image processing. Now we are going to see about the morphology. It is a branch of biological that deals with the format and structure of animals and plants. Mathematical morphology as a tool for extracting image components that's useful in the representation and the description of region shape. So, what are the application of morphological image filtering? That is, extend the boundary extraction, skeletons, convex hull, morphological filtering, thinning and pruning. So, the language of mathematical morphology is set theory. So, unified and powerful approach to numerous image processing problems. Sets in mathematical morphology represent objects in an image. So, binary image is equal to 0 to black. One means white. Same as gray cell image that coordinates x comma y. It will take 256 values. If you have two variables means you will take 0 to 256. That is image given to the morphological image processing. Then output will be attributes extracted from image. So this is a basic concepts in set theory. So already we discussed the logic to operations, structuring elements. Here onwards we need to define that erosion is used to for shrinking of elements A by using element B. Erosion for set A and set B in Z square is defined by the following equation. So that is this equation indicates that the erosion of A and B is the set of all points Z such as B translated by Z is contained in A. So erosion can be used to shrink or thin objects in binary images, remove components. Erosion is morphological filtering operation in which image details smaller than the structuring elements are filtered and removed. So this is a basic example for erosion. Suppose that the structuring element is a 3 cross 3 square. So note that in subsequent diagram, foreground pixels are represented by ones and background pixels are zeros. So the structuring elements is now superimposed over each foregrounded pixel in the image. If all the pixels below the structuring elements are foreground, so pixel then the input pixel return its value. But if any of the pixel is a background pixel, then the input pixel gets background pixel value. So next one is dilation is used for expanding an element A by using structuring element B. So dilation of A by B and is defined by the following equations. That is, this equation is based on obtaining the reflection of B about its origin and shifting this reflection by Z. The dilation of A by B is the set of all displacement Z such that B and A overlap by the at least one element. So based on this interpretation, the equation of 9.2:1 can be written as like this. Relation to conventional mask, that is flipping and overlapping. This is the dilation example. Example 2. So this is erosion with dilation. That is, erosion means shrink or thins objects in binary images, remove image components, uh, away the boundaries of region of foreground pixels, area of foreground pixels shrink in size and holes within those areas become larger. So dilation grows or thickness objects in a binary image, bridging gaps, fill small holes of sufficiently small size. Then opening and closing. Opening means smoothing counters, eliminates protrusions. Closing smoother sections of contours, fuses narrow breaks, and long thin gulps, eliminates small holes and fill gaps in contours. These operations are dual to each other. These operations can be applied few times but as effective only once. Then opening the first erode A by B and then delete the result by B. In other words, opening is the unification of all B objects entirely contained in A. So this is an example, erosion and opening concept. This is the use of opening and closing for morphological fingering concepts for identification of fingerprint in the different concepts. So next on the hit or miss transformation, the basic morphological tool for shape detection. So let the origin of the shape be located and its center of gravity. If we want to find the location of a shape, say X at larger image, say A. So let X be the enclosed by a small window, say W. The local background of X with respect to the W is defined as the set of difference W minus X. So apply erosion operator of A by X will get us the set of locations of the origin of X such that X is completely contained in A. It may be also viewed geometrically as the set of all locations of the origin of X at which X found a match hit in A. So apply erosion operator on the complement of A by the local background set, that is W minus X. Notice that the set of locations for which X exactly fits inside A is the intersection of these two last operators above. Formally it is denoted as like this. The reason for using this kind of structuring element is based on the assumed definition that two or more objects are distinct only if they are disjoint or disconnected sets. In some application, we may interested in detecting certain pattern of ones and zeros and not for detecting individual objects. In this case, a background is not required and the hit or miss transformation reduced to simple erosion. The simplified pattern detection scheme is used in some of the algorithm for identifying the characters within a text. So basic morphology algorithm, that is applications are boundary extraction, region filling, extraction of connected components, convex skull, thinning, thickening, skeletons, and pruning. So the basic boundary extraction concept. Region filling, extraction connected components. This algorithm extract a component by selecting a point on a binary object A. Works similar to region filling, but this time we use in the conjunction object instead of its complement. Yeah, A is said to be convex if a straight line segment joining any 2 points in A lies entirely within A. The convex cell H of set of S is the smallest convex set containing X. Convex differentially is the set difference H1SS. Useful for object description. So these are the basic applications. So thinning and thickening like that we will see in the next class.